Okay, we are still talking about 4.6 and 4.7, and now we're going to do some problems involving what we call rate time problems. Remember we did distance equals rate times time. We had a few problems like that. Now we're going to, and a lot of times the distance was the same, and that's what we were figuring out, or um, the distance was the unknown, and that's what we were figuring out. But now we're going to look at some things called uniform motion problems. And the key here is that the time is going to be the same for two different objects or people. And so we want to rearrange this formula and solve it for time. And all I'm doing is dividing both sides by r and arriving at this new equation that distance divided by rate equals time. I mean, we do this um, sort of without thinking about it sometimes. If you traveled 100 miles at 50 miles per hour, distance is 100 miles, rate is 50 miles per hour. How long does that take you? 2 hours, right? Okay, so let's look at this first problem. An airplane travels 2,050 miles in the same time, this is the key, in the same time that a car travels 260 miles. So we know the rate of the plane. No, we don't. It says the rate of the plane is 358 miles per hour greater than the rate of the car. So, of course, the plane is going faster, right? This is faster. So, we're going to use this formula. The time is the same. So, we set up these two ratios, distance over rate for the plane and distance over rate for the car. Um, let's let r be our variable and let this be the rate of the car. Then what is the rate of the plane? Well, it's hidden in here somewhere. It's 358 miles per hour greater. Okay, so I have the rate of the car, the rate of the plane. We have the distance of both of those. So let's set up our ratio. So we're using which way? The distance of the plane. So this is the plane. Goes 2050 miles. And the rate is r plus 358. And for the car, we only go 260 miles, and the rate is r. Is that what we said? Yeah. And the time is the same. So we set these equal. We don't really need that m there because that looks sort of like a variable. Now what do? You guessed it. We're going to cross multiply. So 260 times r plus 358 equals 2050 r. Cross multiply. Now we just solve. So what is this? 260 r. I have to use my calculator for that one. Plus 93,080 equals 2050R. Now, I'm going to subtract 260R from both sides because I don't want to have a negative rate. Okay, so I just got us some more room here, and we're subtracting 260R from both sides. So I have 93,080 miles equals what? 2050 minus 260, 1790R. What do I do next? You got it. Divide by this coefficient in front of R. And hope that that number comes out sort of reasonable. Doesn't look promising right now. Huh, surprise, surprise. 52 equals R. Okay, so the rate of the car is 52. So we know R equals 52. That's the rate of the car. And what is it in? It's miles per hour, right? So R equals 52 miles per hour. Miles per hour. And then the plane is going 52 plus 358, which equals what? Oh, I got 410 miles per hour. So there are my two answers, the car and the plane. All right. So if you have a problem like this where the time is the same, you set up your ratio, distance over rate for the one side is going to equal the distance over rate for the other side because the time will be the same. So that's what to look for. These words, in the same time. Then you're going to use this technique. Now, these are the problems that I find a little difficult, to be honest. Rate time problems is because getting used to this idea of how we set it up is a little bit tricky. So here, the first thing you can think of, like if a machine can make 150 items in 10 minutes, the rate is 150 items divided by 10 minutes. So it makes 15 items per 1 minute. 15 items per minute. Now, this is what gets a little strange. If a person can do a job in 3 hours, we say that they can do one job in 3 hours. So the time is always down here, and whatever they're doing, they call it Q in our book, is here. Quantity over time is the rate time problem. And here is that explanation. So you'll see when we do some examples, it's a little bit weird to think about writing things as quantity over time, but that's what we're going to do. So here's a good example. All right, let's read the problem. It takes Amy twice as long to deliver papers as it does Nancy. Together, if they work together, they can deliver the papers in 40 minutes. So how long does it take each girl to deliver the papers by herself? We want to know if they can do it together in 40 minutes. How long does it take Amy to do it? And how long does it take Nancy to do it? Who takes longer? Amy. Amy takes twice as long. Okay, so what do we know so far? Together, their rate is one job for 40 minutes. So that's key to be able to set that up. They complete the job in 40 minutes. So I chose to let M be the time that it takes Nancy to deliver. She's the one who can do it quicker, right? It takes Amy twice as long. So Amy needs twice the time. So that's 2M. So together, they complete one job in 40 minutes. Nancy's rate, one job in M minutes. Amy's rate, one job in twice as long. So how do we set up an equation? Well, together, that means we take these two things and add them. Together, they're working together now. Let me make that better. So this is their combined rate, and that equals 1 over 40. So there's my equation. If I can get to here, this is really the hard part, is getting to the equation. But if you can get to here, then you can solve it. Okay, so again, we took Nancy and Amy, took their rates, add them together. That's what this says. Together, it should be 1 over 40. So here's my equation. How do I solve this? Well, we can multiply by the least common multiple of M, 2M, and 40. I can just see that this is going to be 40M because I need, if it's a multiple, it has to be a multiple of 40. 40's already got a 2 in it. M's already got an M in it, so we multiply everything by 40M. All right, let's try that. So multiply this by 40M, multiply this by 40M. Now, there are other ways to solve this. You could go through and get a common denominator and add on the left-hand side and then end up cross-multiplying. But I like to get rid of the fraction. So what happens when we multiply 40M times 1 over M and 40M times 1 over 2M and 1 over 40 times 40M. Simplify each of these. Hopefully you're getting the hang of this now. This is 40, isn't it? The M's cancel. 40 times 1 is 40. Here, the M's cancel. They're equivalent to 1. And of course, we're assuming M does not equal 0. So what's 40 divided by 2? 20. And what do we have on the left-hand side here? I mean, right-hand side, sorry. The 40's cancel, and we're just left with M. So what do we know? M equals 60. Now, what was M? M is the time it takes Nancy to deliver in minutes. So Nancy, is that right? Yep, Nancy delivers in 60 minutes by herself. And Amy takes twice as long. So Amy delivers in 120 minutes. Okay, so this solving the equation is kind of the easy part. Setting up the equation is the hard part. So I hope you will look at these examples. Now, this is homework problem number 10, by the way. So now let's take a break and then we'll work the rest of these problems.